All right, lesson 7.5. We're going to start with learning how to graph quadratic functions. But 7.6 is where we will do a little bit more involved algebraic work before we start the graphing process. So it's going to be an important lesson. It's going to be something that continues into 7.6. So we're graphing a quadratic function. This form here that you see is called vertex form. Sometimes it's also called completed square form, which we'll do in lesson 7.6. But before we get into vertex form, let's just talk about the basic shape of what a quadratic looks like. I've asked this question in class. Most people have been able to respond that the basic shape of a quadratic is a parabola. So let's talk about some of the features of a parabola. Just by picking points. Let's say we were going to plot a few points. So let's choose to plot 0 and then a couple points on either side, like -1 and -2 and +1 and +2. So if y is equal to x squared, so if I plug in these x values to the function, then I'm going to get, if I do -2 squared, I'll get 4. -1 squared, I'll get 1. 0 squared is 0, and then you see 1 and 4. So you can start to see that basic shape of a parabola. Let me see if I can zoom in on this. So we have 0, 0. We have -1, 1, and 1, 1, and then 2 becomes 4. 1, 2, 3, 4. Going cross-eyed. So here's the basic shape that we have, that parabola. Oop, I just missed. You get the drift, though. Okay. Let me zoom out. So a couple of features of that basic shape then. It's symmetric. In this case, it's symmetric about this x-axis here. This is called the axis of symmetry. Symmetric about the y-axis. So that is at the point x equals 0. That's the line that I just drew. I made a dotted line at x equals 0. A couple other things you can notice, the x-intercept and the y-intercept are both right at that point 0, 0. So that's the shape of a basic quadratic without being shifted or moved around at all. What we're going to learn today is how each of the other variables in this vertex form affect the shape in the graph. So this y equals x is assuming in vertex form the a is 1, the h is 0, and the k is 0. So you see, if I would just simplify that, I would get y equals x squared. So now we're going to learn, well, what happens when we make the a something other than 1? What happens when we make the h something other than 0 and the k something other than 0? And what do those letters represent? Okay, so let's just take it one at a time. So the first thing that we're going to do is look at what the a value does to affect the shape of that parabola. So here's what you need to look at. You need to look at whether it's, first of all, positive or negative. So if a is positive, it says it opens up. What that means is it looks like the picture that we just drew, where it's the parabola is facing up. But if it's negative, I'll do it in a different color, what that means is it's flipped upside down. It opens down. Another thing to know about the a value is it also affects how skinny or wide the parabola is. So if a is greater than 1, so it's greater than 1, it makes it skinnier. So it actually becomes a parabola that would, look more like this. This is just a sketch, but it still intersects at 0, 0, but it's skinnier. If it's less than 1, it's a fraction, then we're going to see that we get a value that makes it wider. And then if it's equal to 1 is what we did on the first slide. That's just the basic shape of a parabola, centered at 0, 0, with the other points at 1 and 4 for x equals 1 and x equals 2. So what you should know about A are those key points, is that positive versus negative, opens up versus opens down. A greater than 1 makes it skinnier than the normal graph from the first slide, and A less than 1 makes it wider than the normal graph from the first slide. Okay, moving right along, the K value. So the K in this vertex form, changing that value is going to affect the vertical shift of the graph. So if it's a positive value, rather than it being centered at 0, 0, like the graph on the first slide, it's going to be shifted up. So it'll be the basic shape, but it won't start at 0, 0 anymore. It'll be started a lot higher than that. Or depending on what the value is, if K is 1, then we move it up 1. If K is 2, we move it up 2. Negative moves it down. So instead of starting at 0, 0, it would start somewhere down here. That point of symmetry, that vertex would be lower. So K affects the vertical shift. You probably could have guessed it then. If we had something affecting the vertical shift, then we're going to have a variable that affects the horizontal shift. So that's the H value. So the H value moves it to the left or the right, and I have two little examples here. X minus 4 moves it to the right 4. So instead of starting centered at 0, 0, it would start at the point 4, 0. The vertex there. These are just rough sketches. Whereas x plus 4 moves it to the left 4. So that vertex point would start, instead of at 0, 0, it would start 4 to the left. So negative 4, 0. So you do have to be a little bit careful with the signs here, because this is a minus sign in parentheses. So when it's x minus 4 like you see here, negative 4 actually moves it to the right. If it helps you to think about it, you could think of this as being x minus positive 4, and this bottom one you could think of x minus negative 4, making sure that these are minus signs to match the original equation, which is up here. And then you can think of it as when it's positive, it moves to the right. When it's negative, it moves to the left, which is a little bit more intuitive. Okay, so let's kind of put this all together and talk about the features that you are going to be graphing when we put it all together. So the vertex is centered at the point H comma K. That makes sense. If K tells us where we are vertically and H tells us where we start horizontally, then H comma K will be that vertex. Remember, vertex is that point of symmetry. So it's either the minimum or it's the maximum, depending on which direction your parabola faces. And that's always going to be, directly through your axis of symmetry. The line of symmetry then always goes through the x coordinate of your vertex. So it'll be a line at x equals and then whatever your h value is. Then the other things that we'll do is, in order to graph, is we'll find our x-intercepts. Remember, you can always find an x-intercept by setting your y equal to 0. And you can find your y-intercept by setting your x equal to 0. So those are key features that we'll graph. On your graph, every graph will need to include a vertex, the line of symmetry, the x-intercepts, the y-intercepts. Then you can choose a couple other points to help you kind of connect the dots better and get a good shape for your parabola. When I say choose convenient points, I mean choose points that are symmetric around the vertex. And I'll show you what I mean on the next slide, but like in the first slide, when I found that my vertex was 0, 0, I also looked at the points -1 and -2 and 1 and 2. So I picked points that were symmetric on either side of the vertex and figured out what all of these points were to help me complete my picture. So that's what we'll be doing. Okay, so here it is. We're finally going to do an example where we put this all together. Now, the first thing that you have to notice is this is not in vertex form. So in vertex form, y is isolated, so we're going to need to make sure that we do that here as well. So to get y by itself, I can see that if I have a 1/2 on the left-hand side, multiplying by 2 on both sides will get rid of this 1/2. So I'll end up with, let me put it over here, y plus 6 plus equals 2 times x plus 1 squared. Now I'm not going to distribute any of that right-hand side out because the whole point is for it to be in vertex form. The only thing I need to do to get in vertex form right now is to subtract that 6 from both sides. So I get y equals 2 times x plus 1 squared minus 6. And I'm going to leave it like that because you can see it's in y equals a x minus h squared plus k. So now by having it in that form, I can identify all of those features that I need. So let's start with the vertex, hk. So remembering that this is always a minus h, we can find here that our h value here, if it's positive 1, then it's actually the point -1 for our h value. And then k keeps the same sign, so if it's -6 here, then the y-coordinate of your vertex is -6. So that means on the graph, that's where our vertex is going to be. It's also where our line of symmetry is going to be, so at that h value. So x is equal to -1. So let me go ahead and put those two features on the graph. I'm going to zoom in a little more so I can see. So we have the vertex -1, -6. Here that is. And then our line of symmetry is just an imaginary line. So you're going to use a dotted or dashed or dotted line to show that it's not really there, but it's that line in which the parabola is going to stay symmetric around. All right, let's back up and get these other features. To get my x-intercepts, I'm going to go ahead and set my y value equal to 0. So if I do that in this equation, I'm going to kind of have to do it off to the side here because it takes a little bit of work. So I'm setting y equal to 0. Hopefully you recognize the fastest way to solve this quadratic. Again, it's not to distribute everything out. What you're going to do is just isolate the quantity x plus 1 squared and then take the square root of both sides. So I'll add 6 to both sides. Divide by 2. So I'll get 3 equals x plus 1 squared. And then I'll take the square root of both sides. So I'll get plus or minus root 3 equals x plus 1. But I'll go ahead and just subtract the 1 to the other side. Now, go ahead and put this in your calculator because you might have trouble approximating what that point actually is if you don't. So if I put that in my calculator, I see that I get approximately -2.7 and approximately 0.7. So those are the values where I hit the x-axis. So if I zoom in here, I'm going to have -2.7, so almost -3 on the x-axis. And then 0.7, so just a little bit more than a half. I'm going to do my best to show that on this graph here. Okay. Another feature that we need to get is the y-intercept. So for the y-intercept, we set the x equal to 0. So in this equation, then I'm going to just deal with it in vertex form. So we have y equals 2 times, we're putting x as 0, so x plus 1 squared minus 6. So if we solve that, we're just going to get 2 minus 6 or -4. So that's where it intersects the y-axis. So I come down here, count down 4 on the y-axis. Let's see what color can I use here so you can see it. I'll use this like purple. So -1, 2, 3, 4. So you can see that. Okay, so you should have a pretty good idea here of the shape of your parabola, right? So we have a parabola that looks like this. It's pretty skinny, which makes sense to me because my a value is this +2, which if I look back at my previous notes here, when a is bigger than 1, it makes the parabola skinnier. but we still can pick some convenient points to kind of complete the dots there, right? You know, we don't really know what's happening right in here. We don't have any points any wider than that. So maybe let's just choose a couple other convenient points, and then we can throw a few more things on the graph. So when I say convenient, I mean you want to pick some points that are symmetric around your vertex. So if your vertex is at the x-coordinate -1, then also like try 2 on the left of that and then 2 on the right of that. Again, the only thing that you do here is you plug in, right? So I have my whole formula, and I'm just going to first plug in -3 for my x, and then -2, and then 0, and then 1. I'm going to go ahead and just tell you what you get here. So you get 2, -4, -4, 2. And again, that should make sense. It's symmetric. Those values should match. So let me throw those on the graph, and then we'll just connect the dots, and we'll be done. So what did I say? -3, 2. So we get something like right here. And then 3, 2. Symmetric. I feel like I missed 1, 2, 3, 1, 2. Oh, sorry. This is 1, 2. Okay. And then we also have the point -2, -4. So that's over here. And then 2, -4. Wait, -2, -4. Sorry, I keep doing that. And then the point 0, -4. I'm just taking the, which we already have. That's the y-intercept. So sorry if I just confused you there, but I was trying to look back and forth here, and just all I did was plot any of these points that weren't already on there. So this vertex was already on there. This one happened to already be on there because it was our y-intercept. So I just plotted this point, and this point. And now I just have a little bit more of a continuous parabola to go ahead and connect. So let me do that now. And we are done with this problem. The most important thing is parabolas are curvy at the bottom. They're not sharp. They're not a V. So even though this is pretty skinny, make sure that you focus on this point right here, and make sure you have a rounded curve there when you go through that point, not a real jagged V. And let me just back up so you can see everything. That's a good example of graphing a parabola, where you have to do all of these steps. Okay, the only other thing I can do in this lesson is ask you to do the reverse. So there I gave you the equation and asked you to graph it. Here I'm just going to give you some specific information, and you have to come up with the equation. So here you're not given the equation, you have to find the equation. So that's why I'm saying it's kind of like doing this in reverse. So they gave you some of the graph features. They give you that the vertex is 1, -2. So if we know vertex is HK, and you're telling me it's 1, -2, then I know h is equal to 1 and k is equal to -2. So far, so good. And then they told me another just random point on the graph. Okay, well, let's plug in what we have so far. So here's vertex form, y equals a, x minus h squared plus k. We know h is 1, so I'll plug that in. And we know k is -2. So the only thing we don't have is our a, which is why it's really useful here for me to have this other point, this 3, 6. So if I plug in 3 for my x, let's just say x, and 6 for my y, then I can solve for a. So 6 for the y and 3 for the x. Now the only thing we don't know is the a, and we can temporarily solve for it and then put it all back together. So this is 6 equals 3 times, oops, not 3, a times 3 minus 1 is 2 squared minus 2. So that's 6 equals 4a minus 2. Now you should be able to kind of see it here. We're going to get 8 equals 4a. And we'll divide by 4 and get a is 2. So putting it all together now. Equation in vertex form. We have y equals. We found our a is 2. X minus our h is 1, and our k is -2. And there it is. We went backwards and found the equation from the information given. Okay, there'll be a lot more graphing to come in lesson 7.6, but for now, go ahead and check Schoology and try the problems listed for 7.5.